All right, today we're diving into something that's both super fascinating and, honestly, a little bit scary. We're looking at a moment when a really advanced self-driving car saw something completely different from its human driver. So let's get into it and figure out how an AI with billions of miles of experience could make such a basic and dangerous mistake. Okay, so just look at these two pictures. On the left, you've got what the driver is seeing with their own eyes. A crystal clear red left turn arrow. Simple, right? Do not go. But on the right, that's what the car's AI sees. A green light, basically telling him it's good to go. So the big question is, how does an AI that's seen 10 billion miles of road make a mistake like this? So first up, let's just break down the scene of the error. Because this isn't just some harmless little glitch on a screen. This is a real-world situation, and the consequences could have been, well, pretty serious. And here's where it gets kind of wild. The driver who recorded this, he said the car didn't just see the light wrong, it actively tried to get him to make an illegal turn. It actually chimed, that little sound, basically saying, hey, the light is green, what are we waiting for? Let's go. Thankfully, the driver knew better and stayed put. So what caused all this confusion? What was the culprit? It wasn't the actual traffic light at all. It was this sign. Just a simple, flat, photo-enforced sign with a little picture of a traffic light on it. To you and me, it's obviously just a graphic. But to the AI, it saw something completely different. To really get why this happened, we've got to try and see the world the way the car's AI does. It's not about thinking like a person, it's all about recognizing patterns. The technology doing all the work here is called computer vision. And here's the key thing to understand. It doesn't get context like we do. It learns to identify things by sifting through millions of images and finding patterns that repeat. So to an AI, a traffic light isn't a device that controls traffic. It's just a specific arrangement of red, yellow, and green circular patterns. This chart here really just nails the whole problem. A human brain immediately understands the context. We know that's a 2D sign about a traffic light, not a real 3D traffic light telling us what to do. But the AI? Its neural network is just playing a high-speed game of matching patterns. It saw those familiar red, yellow, and green shapes on the sign and bing, it matched it to its giant database of traffic lights. It was a classic case of mistaken identity, just happening at the pixel level. Now, the first thing a lot of people think is, well, the AI just needs more training data, right? Just let it drive more, it'll figure it out. But as it turns out, it's just not that simple. Let's just take a second to look at this number, 10 billion miles. That's the staggering amount of real-world driving data that Tesla's AI has been trained on. I mean, that's an astronomical amount of information. It's like driving to the sun and back more than 50 times over. And that brings us to the central paradox here. With all of that experience, how does it still get fooled by a simple road sign? It seems pretty clear that just throwing more of the same data at the problem isn't the solution. And hey, it's not just us saying it. The driver who experienced this firsthand came to the exact same conclusion. Simply piling on more miles isn't working, because the kind of data you have matters way more than the sheer quantity. And here's exactly why. The vast majority of those 10 billion miles are, well, they're boring. It's just simple driving, straight roads, clear weather, normal signals. The real test for an AI isn't the easy 99.9% of routine driving. It's that tiny 0.1% of weird, confusing, and rare situations, like a picture of a traffic light on a sign. So if more data isn't the answer, then what is? Let's take a look at the smarter, more targeted strategies that are being developed to train these systems right now. Instead of just passively collecting miles and hoping for the best, developers are using way more focused tactics. First, you've got active learning. This is where the car itself basically raises its hand and says, hey, I'm confused by this, and sends that exact scenario to a human engineer to review. Then there's synthetic data. This is where engineers use powerful computers to create millions of virtual simulations of this exact tricky situation. And finally, and this is a big one, it's about building a deeper contextual understanding, so the AI knows a sign is just a sign. And this is the real game changer. The user who captured this whole thing on video, he said it himself. Simulation is the key. You don't have to wait for another car to randomly drive by this one specific sign in this one specific city ever again. You can just build a virtual world and test the AI on this problem spot thousands of times in a single afternoon. That's how you teach it the difference, and you do it fast. This single incident It's not really just about one car or one sign. It actually pulls back the curtain on the biggest challenge in all of artificial intelligence right now, the battle for what you might call the final frontier. And that frontier is all about something called an edge case. An edge case is that one-in-a-million event that you just can't predict. It's a kangaroo hopping across a road in Australia, a couch falling off a truck on the freeway, or a sign with a picture of a traffic light. These are the things that separate a good AI from a truly reliable human-level intelligence. So the key takeaway here is this: the future of training AI isn't about quantity, it's about quality and precision. Real-world data is fantastic. It's what gets you 99.9% of the way there. But to conquer that final, fiendishly difficult 0.1%, focused simulation is absolutely the key. And that really leaves us with a final thought to chew on. We can use simulation to solve all the problems we already know exist. But as AI gets more and more integrated into our world, is the ultimate challenge mastering the known edge cases, or is it preparing the AI for the countless strange, unpredictable scenarios that we can't even imagine yet?